So good morning to everyone. So welcome to this webinar on food packaging. So on the project called Fitness 2. So this project is a EU-funded project, so funded by the Erasmus Plus program of the European Union. And so this project is coordinated by 𝐥𝐤𝐟𝐞, so the French network of food technology institutes. And we have about 11 partners, so 10 full partners in this project, so that you can see on the screen. So mainly European universities and research centers, and also one associated partner. And we are representing 7 European countries. So the particularity of this project is that we developed a first phase of fitness, so during the period 2017-2020. And during this period, we developed one of the largest e-learning platform of packaging globally. And so at the moment, we have about 3 months of lectures on the conventional aspect of packaging, which are online. And so it's accessible, so without needing any account, and so you can duplicate it freely. And so now we are in the second phase of the project, so Fitness 2. And so the ambition of the project is to reach a broader audience in the food packaging value chain, from the chemical industry to recyclers, and to offer also certified courses validated by online tests. And so this second phase of Fitness started in November last year and will end in 2024. So that's why for today's webinar, we will present you both the result of the first phase of Fitness. So for instance, we will also present you the platform with all the training material that is already online. And then we will also present to you the ambition for this second phase. And so here on the screen, you have the agenda of today's webinar. So we will start with a kind of introduction about the challenges related to food packaging. Then you will have a presentation about the fitness platform and the ambition and the evolution in the future. And then we will just finish with the presentation on how to use the training material of the fitness platform, so for the students or for the researchers, etc. So I will give the floor to the first speaker, who is Professor 𝐥𝐤𝐟𝐞, so a physicist currently working at Fraunhofer IVV in Germany. So Professor 𝐥𝐤𝐟𝐞, the floor is yours.
Okay, yes, I will try to share the screen and hopefully everything will run. This was the wrong. Do you see it? Okay.
Yes,
okay.
We can see it.
Very good. Unfortunately, it's a bit small on my screen, but never mind. It's different than in the training session, but okay, I will go through this right now. My task today is to give a short introduction, about 20 minutes, about the past, the present, and the future of packaging and my view upon this. And the outline you can see here. First, a short historical overview, the overall significance, what is important in packaging. Then the importance of packaging is symbolized by the packaging functions, technical developments for the future, and some final conclusions. So the first overview I will give is the technical developments that took place over, let's say, centuries or even more time. We start 10,000 years past with the first packagings made by ceramics. Today we have a lot of plastics that are the majority of the packaging material. In parallel, we have manufacturing processes, which you can see here in the timeline, which started a little bit later, about 200 years ago, with paper making and other things like this, and which today are at the more advanced plastics conversion technologies. In parallel, we also had the development of food technology, so to say, with a very basic start with drying and sorting. And today we have things like aseptic and modified atmosphere packaging. And I will go into a little bit more into detail in the next slide. And finally, we have a development of the retail, which did not start that early. It started about 150 years ago with the first pre-packed goods, and went over after World War II to the supermarkets, and today we have e-commerce. So to say all these things together characterize and give the necessary requirements for packaging. And today we have to face new targets. First, on the food side, we can say that in the past and also in non-developed countries today, the main target is just to keep the food in a somewhat consumable way. Today, in the more advanced statuses, the requirement is to keep the food in high quality and to keep it at a high shelf life. So this is a progress over the years. And this, for instance, is represented today by, for instance, active and intelligent packaging. But also, it's not so long ago, just about 40 years, that shelf life dating was introduced. So these things together give one basic requirement set to the packaging. But 50 years ago, we had the famous paper of the Club of Rome, Limits to Growth, which introduced the basic concept to reduce environmental impacts. And these came more and more into packaging too, starting in the 1990s with the first official targets for recycling and recovery. And also the idea of circular economy was created at that time. We have the German packaging ordinance as the first example of this development. And today we are dealing with microplastics, and we think at the moment that circular economy might be a solution to these problems. Okay, so to say, as interim conclusions, we had technical developments together in materials, manufacturing processes, and food technology, which needed some time to achieve today's high standards. And you see from the timeline that if you know about the state of the art today, it's not too difficult to have a prognosis about that, what will be happening tomorrow. So this is one important point. That's why we created also this fitness project, that everyone has the chance to get access to the latest state of the art in a well understandable way. Okay, the significance of packaging. Many people, if you ask a standard consumer, do not even know about the functions of packaging. And the most important function of packaging is to reduce food losses. And this is just shown in some sentences here. We have the problem that infrastructure and also lack of packaging leads to large food losses, which may be up to 2/3 of the whole food that's being harvested and generated. And also the European Parliament detected that this is an important issue. And so the food waste reduction target has been set up by the European Parliament in 2017. And the food reduction target should be 30%. Food loss reduction target should be 30% in 3 years' time and 50% in 8 years' time. So this is an important issue that has to be looked at in parallel to the targets for packaging. And to show this a little bit more in detail, you see the losses in the food supply chain. We start up here at 100% from the arable products. They are harvested. They go to the status of being harvested with some losses between about 4 and 15%. These are figures from the FAO from 2012. And I took here the maximum, the minimum and the maximum of losses for different food groups. So don't try to add up these figures because they belong always to one food group, but it must not necessarily be the same. So we go further to processing. We have the processed food, which can be then distributed. It's being consumed here. And in the end, we have the food at the consumer. And you can add up all these figures down here to a point when nearly in non-industrialized countries, nearly 2/3 of the products can be lost at maximum. In the industrialized countries, we have a shift of the focus. Here, the maximum of losses do not appear in the pre-stages, but the maximum figure is here in the consumed food. So in industrialized countries, the consumer is the main source of food waste. But in any case, depending on the focus on the consumer, does he need just food to consume or does he need food at high quality? Packaging plays a large role to avoid these food losses. So let's say some interim conclusions. Packaging is important, and the protective function of packaging is the most important factor. Also in terms of environmental compliance, because the loss of food is much more severe than a loss of a packaging or the environmental cost of a packaging. So in total, you probably learned about the packaging functions PCCC, which is the common term. I would say we should add a fourth C down here to conservation, because the environmental function of packaging is important and often neglected. So in the future, we will see an increase in the environmental function, in the importance of the environmental function, but what we will not see is a decrease in the other function, because they will remain as important issues. So I will just show some examples on these, shown with these arrows: protection, convenience, and conservations. For time reasons, I will not expand the presentation more. And first, this is what we understand by protection. The packaging, the packed goods in here in the packaging have to be protected by the packaging from different external factors, be it oxygen, water vapor, light, and other things, even some very seemingly trivial things like insects or microorganisms, which are also a very important source of food degradation. So the protective function is a thing that is not independent of the food. So it has to be adapted to the packed product, and this is not an easy task. This is also one of our important things we compile in the fitness project to make all this kind of knowledge available. And another thing which will be also tackled later on is that the packaging itself has to be pure and should not transfer contaminants to the packed goods. So next step, convenience. Many people think that convenience is just a luxury that can be avoided and that only creates additional environmental loads. So if we look at the different functions that are associated with convenience, we have this, for instance, stacking aid, portioning, easy opening, reclosability, a lot of requirements we all like to have as consumers. The question is this just a luxury or is it more? And if you look into reality and the scarce figures you get from the retail, it's always the case that packages with a better convenience also show a lower food loss. And this is because the food is protected in a better way if you put it into smaller portions instead of packing it in bulk, for instance. Or if you have a piece of meat that you can consume in even 3 weeks' time instead of 2 days, this also creates a lot of benefit because the number of losses is reduced. So to say, convenience is more or less a thing that is looked at in an ambivalent way. The consumers like it, and they, by the way, even if they say that they think it's superfluous, the practice shows that they will buy it in any case, but it also leads to reduced product losses. So finally, the environmental function, also called conservation in this presentation. It's also an ambivalent thing. We have a positive way of the environmental function of the package. This is given by reducing product losses, and we have a negative contribution to the environmental function because it creates waste and environmental loads. And what we have to look at is the balance between the positive and the negative environmental function. And this is not always easy to find. So just to look at the treatment of the packaging waste, that is state of the art today. If you would look at this, you would say, okay, we have some recycling targets given by the EU, which is met by most of the European countries. This is this line. Okay, we have some increased recycling targets for 2025 and 2030, which are higher, but even this seems to be manageable. So are we on a good way? The answer is no, unfortunately not, because if you look at the real figures, you will see that even if recycling takes place, most of it is used in open loop recycling circles, which means that it's the recycled material is being used for other purposes. And because packaging is the major application field of plastics especially, this is not sufficient, because what we need in the end to have this very often apostrophized circular economy, we need closed loop recycling instead of open loop recycling. And this is more difficult. You see from the shallow figures, worldwide only 3% of the plastics are recycled in closed loop. In Germany, it's 11%, but it's still far below the number we need. So this is also the outlook for the future. We need this closed loop recycling, and we need processes for closed loop recycling. And we have to develop better recyclable packages. Just some examples for this. What is a recyclable package? A recyclable package in this context is something that can be recycled and be reused in another package. And this only works if you don't have too many disturbing components of the package. So in this case, for instance, we have a package with some EVOA barrier layer, with EVOH barrier layer, which can be recycled together with the other plastics if it's not too much, if its thickness is low enough. Another example, biaxially oriented polypropylene, we use a barrier layer here to increase its barrier function. This is laminated with an adhesive to another polypropylene. Theoretically, we have polypropylene with some small amount of additives, but depending on the thickness of the adhesive, it may be a disturbing effect. So this is something that's critical. More easy is, for instance, this example, a thick polypropylene film that has been thermoformed into a container covered by a thin barrier material. So in this case, you see that there is still a long way to go to develop more and better recyclable materials, which at the same time give enough barrier function for the packaged goods. So also, finally, the recycling processes need to be improved. And if you see this quite complicated sequence of steps that are relevant for used packagings, you see that there is a lot of points where you can enter. For instance, you can select possible contaminating packages. This is here represented by the A. You can apply macroscopic cleaning, and you can even try to remove contaminating molecules within all this process line. In the end, you have to meet the requirements of food contact laws. And this is not easy. So if it's required that you have a direct food contact, there is an alternative by solvent-based recycling, which helps to make a better purification because the polymer has been dissolved before. And you can then just see from this comparative example what the difference is between mechanical recycling without this dissolution process. You see the contaminants in the plastics. And if you have the option to dissolve it and to clean the solution, you can get a pretty much better quality of the recycled polymers. So these are, in brief words, the options we have, the past, the present, and the future. And in the future, I would say we should never forget that the product losses are the most important things a package has to work against. But we need also to introduce a circular economy which will trigger a lot of new technical developments. On the other hand, I would say that new developments we discussed about the last 20 years, like active and intelligent packaging, have to be viewed quite critical in this context, because we cannot simply add new components to the packagings over and over. And therefore, I think there will be a competition between these developments here, the technology developments for circular economy, and some new functions that could also be introduced into packaging. This will be a difficult balance. And finally, and I didn't talk about this too much, but I would like to add it, novel reusable systems will also be entering the market in a more pronounced way. Okay, that's my presentation. Thank you very much for the time being.
Thank you very much. Also, so please don't forget to, if you have any questions, so you can ask them in the chat, and then you will have time at the end of the session we can ask them to the speakers, and they will answer. So don't forget to send your question in the chat. So thank you very much, Professor Langowski. So now we will continue with the presentation of Olivier Wittrak and Stewart Waddy. So Olivier Wittrak is a senior researcher at 𝐸𝐼NRAE, so the French National Institute for Agriculture, Food and the Environment. And Stewart Waddy is an engineer in software engineering. So the floor is yours.
Good morning, everyone. I'm not sure that I'm sharing entirely my screen. Do you see entirely my screen?
Good morning, everyone. We can see your in private browsing.
Yeah.
But do you see a window, or do you see the entire screen?
Just a window.
Ah, that's a problem. Stop share, share again. That means screen share. Do you see the entire screen now?
Yes.
Yes.
Okay. That means good morning, everyone. We play a little because we have a big claim. That means education could be a solution. That's something that we put really strong in the project, and we develop a platform to teach, to train people. The only thing that you have to type either with a Microsoft Bing, it's fitness, not fitness only, please. Currently, it is hosted by 𝐸𝐴GroPyTech. You type fitness 𝐸𝐴GroPyTech. That's the first link. Or you do the same in Google. You type fitness and 𝐸𝐴GroPyTech, and that's the first link. You click on the link, and you have this web page. I will put it full screen. And for the presentation, the talk of today, that means we made below in the teasing a webinar. You click on the webinar, and then the technology of fitness starts. What is this kind of technology? Just to share a little with you, we are within a browser. That's really important first. That will work with any kind of a screen. That means that's capable to work. No, that's not what I want. Anyway, that works. You can use it to your smartphone, tablet, anything. That's it is working. The tools that we have, it's not PowerPoint. The way we can browse horizontally and we can browse vertically. You will see I will play a lot. We can have a video, we can have things dynamic. That's one of the main tools that we have to deliver content to you when they have been developed with based on PowerPoint. Then I start with the first slide. Also something that for teachers, that for those that need to teach, I can use even a second screen. That means I have access even to the time I spend. I will put it. I have two screens, and I will use it. Then for this talk, first we'll start with the context and the ambition. that means the context has been really clearly explained by host Christian Langowski. That means things have changed a lot during the past year. And I just to show you, that means some kind of content that we can have, that means on the platform, just to explain how things can be really complex. That's
Maybe-
images from the French TV that's
maybe you
based
can
on
have it
archives
in
in
full
60.
screen maybe.
I mean, do you see the video or it's not working?
Yes, it is working.
Ah, I need to start it. Okay. The video is working?
Yes, it is working. Maybe you can increase your browser because we don't see the all the browser.
That means now, that means on the platform, you can have video full screen. You can have, I mean, you have access to many things to explain a really complex concept. But if you are curious, that means the video that I made based on things available online, that's to explain the recycling. That means in 64, the first bottle in PVC were put on the market. In 74, in France at least, that means that was the end of returnable bottles. Then that means that there was in glass, everything was shifted to plastics. 21, that means we want to recycle massively. And this year and ongoing years, we want to have something in closed loop. And we think that what the solution is to educate oneself. That means to have access to the last knowledge, not only for students, but also for professionals, because it's really a complex subject. And to find the balance between minimizing food waste and minimizing environmental impact is quite complex. You have a lot of food safety issues that we have to manage, and the law are really changing rapidly. And we have in balance many coercive laws that force to recycle plastic for food contact. And we don't have the solution, to be honest. We don't claim that we have any solution. But we think that the only sensible answer that we can have, it's education. It is a training to share knowledge. And we are, that means in the consortium, we are also scientists. That means we are academics, or we work for technical centers. That means we try to develop solutions. We can explain them. That means we try to put even on the platform of fitness, even the last research results. In this case, it was to explain a functional barrier. That's a solution to use recycled materials. And you see, obviously, that even if you have a functional barrier, if you don't manage them well, you can be more contaminated at the end than at the beginning. And that means it's not necessarily a solution to use less decontaminated materials, or we have to find the right condition for that. That means you can learn all of that on the platform Fitness. Fitness stands for food packaging open courseware for higher education and staff of companies. That means really we try to develop something that is for both public, for both audiences. That means people, that means at the university. And the problem that we have at the university, if you learn chemistry, you don't learn food safety. If you learn food engineering, for example, you don't have a strong background in material science. And now with the circular economy, we need to learn everything, because everything it's linked. We have to consider linked decision. It's why to have a platform with large content is useful. We provide two kinds of content. You have what we call a common content. I can put also again full screen. That means you have a common content, it's just the basics, and you have an advanced content that is closer to from research results from the literature. That means all the content has been developed by people from university, academic, or technical laboratories, useful for the industry with the intent to develop a responsible packaging. In fitness use, something that we will discuss a little later, the intent is to use this kind of tool also in graduation program and to offer some certificates. That something is also the intent of fitness use in order to certify that you reach some level, you have some level of knowledge on what could be responsible packaging. That means the fitness pillar rely on a validated content, an open source distribution format. That means you don't need to install anything. You can use the platform as it is. If you have a problem of bandwidth, for example, you are living in Africa, you have a problem of bandwidth, then you can download entirely once the platform and you can use it. And you don't need any kind of server. And something we offer is we offer a search engine. That means, such as Wikipedia, it starts to be so huge. That means we need to have new tools to search the entire database. You will have an example. That means, what is a platform at a glance in 54 seconds? That means you have to remember you can access by typing fitness 𝐟𝐞. You have access, that means below you have some information and links. But once you say I have understood, you have access to a syllabus with everything there, with a different kind of content. That can be content such as presentation, that can be just books. We offer even entirely books that you could be technical guidance. You can screen, that means you can throw case studies. It's enormous at the content we have. That means you can solve a quiz. It's just 54 seconds to summarize 3 months of training you can have on the platform. And we are still extending it. That means it's really difficult to summarize everything you can find on the platform. Just to explain it a little, you can use any kind of terminal to get access to the platform. Initially, you arrive on a page, just you have to click I have understood, because please, that means we don't provide any guarantee of any kind for the content of the platform. We do our best to be up to date and to be accurate. And from there, you will be able to follow lectures where the platform is completely transparent. That means if you play a little, you will discover that even you have access to the file system. That means it's really an open and expandable platform. That means even people that would like to extend it privately, they could. That means the license is really, really basics. It's open source, and most of the content, except it is mentioned otherwise, can be reused. As I said, it works on any kind of platform. That the way it looks on smartphone. I took the screen of an iPhone 10. Please don't use an Apple Watch. That works, but it's not really needed. You can play with the tip of your fingers. That will work. Sometimes it's small on smartphone. We agree with that. Sometimes it's better to turn your phone to have a better view. It's difficult to manage everything because you have different kind of format. As you saw, I have on my screen arrows to move below or right. You can use that means if you have a tactile screen, you can use the tip of fingers to move it. You can zoom on it. You have a link, you have a detailed view. That means normally the interface will adapt itself to your needs. The kind of content that you can have, you have very various content on the platform. You can have lectures, you can have a reference document, you can have a video, additional reading, you can have a case studies, and you can have help, in particular if you have to resolve exercise, and we provide the solution. That's already, all of that is already on the platform. That means another very interesting feature is the slide search. that means you can search for anything you want. Just a little, I did not make the link, I should, but if you go to the fitness platform, you click I have understood. For example, you are interested in recycling. If you look for anything with recycling, there are 8 lectures that means discussing with recycling. You see the slide of 𝐥𝐤𝐟𝐞, bio-based materials. You see, that means you can find all lectures. And if we give you even the number of slides, for example, if that means for some words, for example, I don't know, if you are interested in polypropylene, propylene, for example, here, that means in this lecture on plastic packaging, we have 2 slides dealing with polypropylene. Or if you click, for example, on this one, you will jump directly to the content of the slide. And you can follow, that means the entire lecture. That means, and you can see whether it is related to other kind of concept. It is quite easy to follow. That means really the search engine is very fast and is really useful for blended learning, in particular for students of professional when they have to write a report, they want to have access to a concept. You see here we type bottles, it will give you everything we have inside on bottles. You can look for regulation. That means you can look on many things with the platform.
Yes, it's really an interesting feature. For example, when we have to search on a concept, but we don't know exactly on which lecture, on which page of the lecture we have seen the concept, you can use the search bar to find the slides directly.
Also important, that means on each slide, that means we have here on the top left corner, you have an additional menu that gives you the relation that between this lecture and the others. For example, it is associated to the topics plastics or polymers. If I was on migration, for example, if I'm clicking migration, it will give me all the lectures associated to this concept. And we have 24 lectures associated to this concept. And even you have you have probabilistic modeling. And you can click on everything. As soon as you see something, for example, risk, you click a risk, you go directly to the concept of risk. Normally, it's very responsive. You should not suffer any kind of delay. Then that should encourage you to learn by yourself. And other feature really important and useful on the platform, you have a mini keywords. You have a help. Normally it's working. I try to have it even today. No, it's working. Okay. It's just the help which is not working. Sorry. A small bug. We have a bug sometimes. Okay. We have, that means you have, for example, escape or O that enable you to go to different parts. You can move up and down. You can have even automated reading. That means the slide can change spontaneously. You have a line at the bottom that gives you, that means how much of the lecture you read. You see, we are close to the end of this one. I will take the example of panorama food packaging, and that was a presentation of 𝐥𝐤𝐟𝐞 today. For this presentation, we had the lecture itself, and we had the video associated to it. For example, if you click to the link, that means directly Can you hear me?
Yes.
Yes, we can hear you.
Yes, I press the wrong button and airplane. That was not a good. That means if you go directly to the syllabus, you will discover that we have part 1, the lecture, and we have video. That means for the lecture itself, you have the summary, the content. Normally, it's 45 slides. It's a lecture of almost 40 minutes. You have this lecture has been recorded during an online session and during a regular session. That means you will have the pleasure also to watch it again with a different quality. When it is an online session, that means it's recorded directly from the screen, not from a camera. That means if I summarize the main features, we have a single tool for teachers and learners. That means for the teacher, for the teacher, that means they have a twin view. That means with a twin view, they can see the time they spend. And I need to accelerate myself. It works online or offline. You can download your lecture and to watch it and read it before any internet connection. It's open source, clonable, already ready for blended learning. I mean, you can mix a different knowledge easily. And you have a link to many of our computational tools, in particular for compliance testing. That means all of that, it's available for free. Now, please, Stewart, if you want to present the Fitness 2 features.
Yes.
You have to share your screen.
Can you see it now?
Yes.
Okay, perfect. So that was the presentation of Fitness 1, and now we will be talking about the Fitness 2 new features, what we want to add. Major release is expected by the end of 2022, and then a new one every 6 months. So on the Fitness 2 new features, we'll have a non-linear training or learning. That is to say that slides are based on your preferences and answers. We have 3 examples here. As we don't have that much time, I will just open them one by one and explain, just explain one of them to you. Example 2. Okay. So this one, for example, is one for a course suggestion, and we have a button here at the top in order to show us the different suggestions that we can have on this lecture. So we click on just start, and here, based on your knowledge on food packaging, you would describe yourself as beginner or advanced. We can choose just beginner, and then we have a set of questions. And which module are you interested in? We have different kind of modules here. We can choose just properties of food packaging materials. Then next step. Here we have a unit. Which units are you interested in? We can just select, for example, here, thermal and mechanical barrier. Click next. And then here, based on our previous choices, we have different courses, different lectures that we can start. For example, if we click here on mechanical properties, we'll directly jump into that lecture. And what do we have other than that? Okay. We have an AI that will guide you to adapt the future content of your knowledge. We also have user authentication based on unique key, possibility to recover previous state. That is to say, currently on the fitness platform, there's no authentication for the learner based on address, email, or passwords. So we will create a system that allows the learner to keep track of his evolution from one visit to another. The learner will be able to see which lectures he has completed, which lectures he is currently working on, etc. Then we will also have the possibility to set up standard tests to evaluate the learner's knowledge. Tests will be available to check what the learner has learned. And we'll also have new content such as interactive case studies. And then it will still be clonable free, no central server and no tracking. And here we have all the contributors of this platform. So these are the contributors, and here just the development team, Olivier and I. So this is just our presentation. Thank you for your attention. And I can just give you the floor, 𝐤𝐻𝐼.
Thank you very much, Stewart and Olivier. So now we are coming to our last speaker. So it's Fatima Pochach from the Catholic University of Porto, and so she's a professor in packaging material and systems. And so it will be, yeah, the floor is yours.
Good morning, everyone. I hope that everyone can see well the screen. So in this presentation,
it's not full screen, Fatima. Sorry. Oui.
How is it now?
Yes, perfect.
Yes,
Thank
perfect.
you.
Thank you. So in this short presentation, I will illustrate how the fitness platform has been used and is planned to be used in the context of food engineering programs. So first, I will shortly review what food engineering is, what a packaging technology or a packaging engineer does. I will shortly indicate how the topics that are covered in our fitness platform, and at the end, very rapidly, a few works that have been developed by our students will be presented. So starting with what is food engineering, first of all, it's academic, scientific, technical, and professional area where principles of engineering and science are applied to food production and operations. So it includes the stages of all food supply chain, from processing, production, handling, storage, conservation or preservation, control, packaging, and distribution of safe and efficient food globally. So packaging is already introduced here in this kind of definition. So food engineering is a multidisciplinary field that rely on food sciences, but also on broader engineering areas. So food engineers, what they do, they use their skills to design sustainable and environmentally responsible food processes for manufacturing safe, tasty, healthy, convenient food products. And in the first lecture of today, Professor Ławoski illustrated very well how packaging plays a tremendous role within this context, and in saving, in minimizing food waste, for example, and food losses, but also being part of the burden. So all this paradigm is complex, how packaging really interacts within the food supply chain. Food engineers need a solid understanding of the scientific basis of food industrial operations, but they also use methods for evaluating and controlling the safety and the quality of the food. They need to understand the effect of the process on food quality, and they go a little behind, and they need to understand the impact of food on health, and we call this as engenomics. Food engineers use modeling and simulation tools to predict and optimize the products and the processes, so virtualization. And they need to innovate in the food distribution chain through a capacity for holistic approach, so open innovation, and more with social responsibility. So food engineers, they intervene in the design, in the planning, in the development and management of sustainable and innovative food systems, supporting the production of high quality, safe and nutritionally balanced foods. And packaging is part of this role. Many years ago, a professor of mine, T. Downs, said that packaging tends to be taken for granted when it functions properly, and it is most likely to be noticed when the bag stretches instead of opening, or the easy open feature fails, or the child-resistant feature is impossible to decipher by anyone other than a child. So this was said very wisely back in 1989. But since then, a lot of things has changed. As in the old sayings, before you said you are what you eat, but now we already passed epoch where we say how much we are eating, and more now we say what is the package of your food. So nowadays the paradigm of packaging is new, and it's required to demonstrate that packaging is reusable, recyclable, or compostable, besides all the important functions and roles that were addressed in our first lecture today. So connecting this food engineering with packaging, more and more we have food technologies that rely in pack processing, both industrial and domestic, like, and I list here a few. More and more we use materials and packaging systems with enhanced functionality and active and intelligent packaging. We are absolutely using bio-based materials and nano-based materials. So all these new developments and innovations also bring new risks. For example, through degradation products, new potential migrants, new hazards and risks as well. So students must also be aware of this aspect. Consumer has an very important role, because consumers are not knowledgeable in packaging. All the studies point on that direction, that increasing the knowledge, the awareness of consumer is very important. And we know that with these advances in food engineering and in packaging technology, more and more intervention of the packaging is delocated into the end of the supply next to the consumer. And we know that as we progress in this direction, from production through distribution to home preparation and end use, the awareness decreases and therefore the risk increases. And this must be taken into account when we teach food engineering and food packaging. So packaging materials and systems in a program of food engineering accounts for 5 to 7% of the program credits. So it's still relevant. And it combines the knowledge that relates to the food and to the packaging system. And this was addressed and taken into consideration when fitness was developed. We need to have teaching paths for teaching packaging that depends on the student's background. If is a student that comes from the food science background or a student that comes from material science. So in fitness, we cover not only the materials and the end use, but also the operations and the processing, and also simulation tools to teach our students how they can get the results faster and better. So packaging engineers, they should design and test food packaging. They should be knowledgeable about packaging and equipment. They must follow the packaging laws. But here in this slide, we also have some soft skills that any professional, but also packaging engineers particularly are involved, like costs, like collaboration with teams, etc. In fitness, we cover essentially these two aspects: the design and test of food packaging and packaging laws, and to a less extent, but also some modules are devoted to packaging equipment. So we have new learning needs, we have new teachers handbook, and fitness really comes into this context, in the very much interaction between the food and the content, and then with the surroundings and with the environment. The fitness topics, and to complement a little bit what was said by Olivier and the colleague, the fitness are organized into different areas that cover materials, and here we tried to be very comprehensive on plastics, metals, glass, cork, paper, and wood, in fact. So we try to be comprehensive and address the properties like mechanical and barrier properties, but all the materials. There are topics on the processes required to produce the packaging, but also to produce a food product within the package. We have some modules that address shelf life, and the impact of the packaging on the preservation characteristics of the food. And we have topics addressing modeling, modeling tools, two different aspects, and one aspect is certainly to model shelf life. We have regulations and toxicology modules where migration, for example, and exposure, estimate how to estimate exposure, and then how to estimate and project risk are covered. And we have a section also devoted to circular economy and environmental safety. Innovations and new materials are addressed, and also under development we have modules more to the secondary and tertiary or transport packaging, where design and the mechanical behavior of the packaging is addressed. So all these topics are addressed, as Olivier and Stuart said, in different levels. And like Stuart also indicated, presently we are coming from a fitness one where important set of materials is already there, and in fitness 2 new contents will be updated and introduced. So this is the overall picture as of the different topics that overall fitness will cover. So this fitness one particularly has been used already in the context of COVID, of course. It can be used as a standalone tools. I used for a few classes, but also as a tool for hybrid classes where the students can be guided and on following the platform. It's very much flexible to be adapted according to the student background. As I explained, depending if we have students from a food science or from a packaging or material science background. And most importantly, and this is where Fitness 2 is really working in, is an alive tool. We'll continue to include new and updated topics and learning assessment. So to be even more useful in the context of academic and universities. Of course, it will not replace the hands-on laboratories, but you are very much welcome to travel and to go through the fitness platform. Finally, I have just a few works that our students developed to illustrate a little bit the areas that we can have. Works performed by packaging students that are within the program of food engineering. So in this case, it was a study about the safety of baby bibs in European market, and it was targeted to screen and to migration potential contaminants and to evaluate the toxicity of, for example, components in printing inks. In this case, the students use modeling techniques to simulate and to classify cork stoppers that are used for a wine bottle. And as you know, we can have corks in natural cork, agglomerated, and so on. And these tools were able to discriminate between different corks. Here we had a student from Italy that visited us and developed a material that is based on chitosan and with incorporation of extract from olive leaves. And this material is with antimicrobial properties. And the last example is a study that was done here in Portugal regarding the relationship between the glass bottle weight and the price of wine, and how this the bottle weight relates to the design of the bottles and how the consumer response and how the consumer is aware of if we have a glass bottle that is lighter, so that less glass was used to produce, so environmentally is more friendly because we use less energy. How the consumers see this once the bottle weight is associated to a better quality wine. And this is a very recent study. So I hope that I could illustrate how this platform is structured in terms of the content and how this content relates to the food engineering and to the packaging teaching needs. And I'll be happy to answer any question. Back to Gemma, thank you.
Thank you very much, Fatima, for your comprehensive presentation. So we didn't receive any questions in the chat for the moment, but now that all the presentation have been done, so perhaps you have a better overview of what we are doing in this fitness project. So please, if you have any questions, so use the chat and we will ask them to the speakers. Also to tell you that so this webinar is recorded and it will be available later on, so you can have an access after it when you want. And you also received the link of the fitness platform in the chat, so please feel free to go there. Also, we are interested to have your feedback about the platform. So thank you in advance for your comments. So it seems that it was very clear because we don't have any any question. So if we don't have any questions, so we can close, I think, the webinar because we are almost on time. So it's yeah, perfect for the time. So thank you, yeah, very much for all of you to be present and to attend the webinar. And in any case, you will receive the future development of fitness by emails, and so you will we will still be in touch with you. So thank you very much to all of you, and thank you again to the speakers.